This problem has a number of interesting parts. I'm going to start with the first one. It says, find the tangent to this curve at the point where the slope is equal to 4. So if y is equal to x cubed plus x, and I want to find the slope of the tangent line at any particular point on that, that is the same thing as y prime. So y prime is equal to 3x squared plus 1. Well, I'm supposed to find out where this is equal to 4. Where is the slope equal to 4? So I have 3x squared plus 1 is equal to 4. That gives me 3x squared is equal to 3. So x squared is equal to 1. X is equal to plus or minus 1. So on my original function right here, I will have a slope of 4 at the x values of 1 and negative 1. You know, let's just graph it just to see if we think we're on the right track. So I put the formula in, I go zoom 6, here's my graph. I might want to look at it a little bit more closely, like from the window of, let's say, I don't know, negative 3 to 3, and we'll graph it. And yeah, does it look like I can have a slope of 4 at x equals 1 and x equals negative 1? I don't know. Could be. It's kind of going up pretty steep right there at that point, and it's going down pretty steep right there at that point. So I'm not going to argue with it right there. It didn't look quite right, but if I want to just check it numerically, I can do that too. So I can go alpha f2 and get my derivative calculator, and I want to do it for the formula that I just put in y1. I want to do it for that equation, and I want to do it with respect to x, and I want to do it where x equals 1. Close parentheses, hit enter, and sure enough, it's 4. So I'm pretty comfortable with my answer now. So at the point where x equals 1, if I plug 1 into my y, I get y equals 1 cubed plus 1. So that would be y equals 2. So I know I have the point 1 comma 2. And if I say x equals negative 1, and I plug that in, I get y equals negative 1 cubed plus negative 1. So I get negative 1 plus negative 1. I get negative 2. So that's telling me I have the point negative 1, negative 2. Which I find kind of interesting, because if I have the point 1, 2, and negative 1, negative 2, just out of curiosity, I'm wondering whether this is an odd function. So I know odd functions are where f of negative x are equal to negative f of x. So in this case, f of negative x would be negative x cubed plus negative x, or would be equal to negative x cubed minus x. And negative f of x would be equal to negative x cubed plus x, which would equal negative x cubed I did that out of sick pleasure, but I did it anyway. So if I go back to my problem here, I have one point at the point 1, 2, and I have another point at the point negative 1, negative 2. I have a slope of 4 at those points. So to calculate the equation of the tangent line, I'll use point slope form. So y minus y1, y minus 2 is equal to 4 times x minus 1. So I have y minus 2 is equal to 4x minus 4. Or I have y is equal to 4x minus 2. So that's one equation of one of the tangent lines. And for the other tangent line, I would have y minus negative 2 is equal to 4, my slope, times x minus negative 1, using my parentheses, not losing negative signs. Y plus 2 is equal to 4x plus 4. Y is equal to 4x plus 2. So those are the equations of my two tangent lines. And if you had wanted to leave them in point-slope form, I don't have any problem with that. This is slope-intercept form right there. So those are the equations of my two tangent lines. But my problem continues. My problem says, what is the smallest slope of the curve? Well, that's an interesting question. The slope of my curve is represented by the derivative, which is 3x squared plus 1. What kind of graph is that going to be? Well, it's x squared. That's going to be the graph of a parabola. And the lowest point on this, and it's parabola since it's a positive leading coefficient and an even number, it's a parabola opening up, up. And since the lowest possible number there is going to be my minimum, which is at my vertex. So I can find out what my vertex is. I can use the old formula negative b over 2a. Well, this is equal to 3x squared plus 0x plus 1. So my b is right there. So I have negative 0 over 2 times 3. Well, that equals 0. My vertex is at x equals 0. Well, when x equals 0, what does y equal? Well, this equals 0. Y is equal to 1. So the smallest slope of this curve right here is 1. I cannot, this is the equation for my derivative, which is the slope of this equation right here. And the lowest possible number that this equation is going to give me is 1. Now, we could have also figured that out just thinking about transformations. So I know if I have the function x squared, I know that's a parabola. And I know that the vertex of x squared is right there at the origin at 0, 0. And I know that 3x squared means it's just going to stretch it up by a factor of 3. It's not going to change where my vertex is. But this plus 1, this k, is going to raise the entire parabola up by 1. So my minimum point right there is going to be at the point 0, 1. Again, showing me that my smallest slope is 1. And that it's going to happen at x equals 0. So let's just kind of take another look here at our graph. So here's my graph, and I can see definitely that the smallest slope on this graph is at x equals 0. But I can't really quite tell what it is because it's a lousy TI graphic calculator and the graphics are crummy, and I can't really see what it looks like. But what I can do, and I know it's the smallest slope because these are all positive slopes right here, and it's getting closer and closer to 0, and then it's positive again. So I never have any negative slopes on that graph. But let's find out what the slope is at 0. So I'm going to go alpha f2, and I'm going to pick number 3, my end derivative function. And I already put the formula into y equals, so I'll go alpha f4, and I'm using the y1. And I'm finding the derivative with respect to x, and I'm finding it x equals 0. And I hit enter, and it's 1. So, confirm. Good problem.